Hello everyone, my name is David Connolly and today I'd like to give you a very brief overview of some research that I just finished recently, which I hope will help transform the way we view electric vehicles into the future. And I think over the last few years, one of the most interesting things to observe is that we've seen with the introduction of the Model S from Tesla that if you can provide a higher quality product than what people have had in the past, then people are more than happy to move from petrol and diesel over to electric vehicles. I think the Model S has demonstrated that a better quality product is something people are willing to pay a lot of money for, even though it is an electric car. Of course, the big challenge for electric cars and other electric vehicles right now is that there's still a perceived compromise in quality of life when they go to an electric vehicle due to the limited range that they have compared to petrol and diesel cars today. And what I'd like to introduce is a new technology which is currently experiencing rapid development, which I believe can not only overcome this range anxiety, but actually make electric vehicles better in terms of range than what we get out of petrol and diesel cars today. Furthermore, not only would it help the range, it will also help us for the first time to cost effectively electrify heavy duty transport like trucks and buses, which would be a huge breakthrough for sustainability, because it's really important that we can start getting electricity to these heavy duty vehicles. To give you the quick overview, I'm going to present a very hypothetical example of how you would go about a journey from Paris to Berlin in a world with and without electric roads. So let's just look at that journey. If you were about to travel today from Paris to Berlin, it would be a total journey of about 1,100 kilometers. And looking at electric vehicles that are on the market today, they typically have a range of around 300 kilometers. The Tesla Model S being an exception, obviously, but I wouldn't categorize that under the affordable vehicles. But a Nissan Leaf, 250 kilometers or so. So let's be generous and say you're getting 300 kilometers per charge. If you were about to travel from Paris to Berlin today, you would have to stop maybe 3 or 4 times along the way to charge your electric vehicle. And for most people, that is a compromise in what they're used to, considering a diesel car, for example, could probably get you 700 or 800 kilometers of that trip before you have to fill up. So let's imagine now you have an electric road in place, rather than looking at today's situation. If you take a Nissan Leaf and it has a range of 250 kilometers, 300 as I've assumed, if we take that 300 kilometer range that we assume for the Nissan Leaf, you could live anywhere within 300 kilometers of Paris, and you could be going anywhere within 300 kilometers of Berlin. If you were in a 300 kilometer range electric vehicle today, you could use the onboard storage to get you from that starting point to the electric road. Then once you get to the electric road, you would connect directly to the road and use the electricity from the road to power the vehicle, and then travel another 1,100 kilometers all the way to Berlin. And then once you leave the road, the other side, you could leave it with a fully charged battery on board, which you charge from the road, and get 300 kilometers anywhere around the Berlin area. This means that conceivably, if this electric road was in place, an electric vehicle with a 300 kilometer range today could actually travel 1,700 kilometers on a single charge. That is much better than most petrol or diesel vehicles can actually achieve right now. So if we have electric roads in place, we can enable electric cars to provide a better quality of life than what we're already used to with petrol and diesel cars. Secondly, if you imagine that you're driving a truck, you could conceivably power the truck via only electricity all the way from Paris to Berlin. So you could provide electricity for a huge length of a journey for a heavy duty vehicle like buses or trucks if you had an electric road in place. I've been following this electric road development for a few years now, and I've come to learn that what most developers are aiming for in terms of developing electric road technology is a development price of about 1.5 million euro per kilometer one way. There's a lot of variations. I identified 17 different people that are currently trying to develop different forms of electric road technology, and there are of course many uncertainties around that development, but some people predict that it can do it much cheaper than this, and others think it will cost much more than this. But I've taken an average of a lot of the projections, and what I would like to show you today is that using this forecast for what developers think they can implement this technology at right now, I believe that electric roads are a very affordable thing for us to do as a society due to the savings that it will allow us to achieve in terms of smaller batteries. So let's just take this 1.5 million euro per kilometre and look at my hypothetical scenario again of building an electric road from Paris to Berlin. This 1.5 million euros per kilometre is for one way only, but naturally if we're going to Berlin we'd like to get back again, so let's assume that for building the road in both directions it'll have a total price of 3 million euro per kilometre. That means for an 1100 kilometre journey at 3 million euros per kilometre, it's going to cost 3,300 million euro to construct the electric road from Paris to Berlin. So 3.3 billion euro. Of course, that's a huge number and it can be a bit overwhelming to think about that at the beginning, but to finish this story, what we need to look at is if we build electric roads, how much money can we save on the other side? And what I mean by the other side is that if we have electric roads in place, we'll need much smaller batteries. So the key to this is looking at how much are the battery costs. And when we look at batteries, there's really two important things that we need to look at. First thing is range. So how many kilometers do we want our electric vehicle to be able to travel? And when we look at the range, I've assumed here for a typical electric vehicle today, it requires a range of around 300 kilometers. Typically, if you look at the efficiency of an electric vehicle, you can travel around 7 or 8 kilometers for every kilowatt hour of battery you have. Now I'm going to be a bit generous here and assume 10 kilometers for every 1 kilowatt hour of battery that you've got. So if I have a range of 300 kilometers, that means for 300 kilometers I'm going to need a battery capacity of 30 kilowatt hours. So what I've just done here is made a relationship between how big is the battery that we have versus how much range have we got. So for a 300 kilometer range, 30 kilowatt hour battery, then the second really important thing is what is the unit price, I assume, to actually build that battery. In other words, what is the euros per kilowatt hour I think I will have to pay in order to build that battery. And the reason that that's so important is because today we're producing those batteries at around 500 euros per kilowatt hour. But if you look at the literature, in the future, there's a lot of people predicting that we can reduce that quite significantly. And the lowest price I've come across for the future right now is a minimum of around 100 euros per kilowatt hour. The challenge becomes that there's only so far you can reduce this due to materials and so on. But what I've seen so far is a 100 euro per kilowatt hour price is the lowest that I've come across. So if we take today's price is 500 euros per kilowatt hour and a future price is 100 euros per kilowatt hour, let's assume the average of these for this simple calculation of 300 euros per kilowatt hour. So now what I've done is I've got a range, I've got a size, and I've got a price for the battery that I have to pay. So the total cost then, if I connect the size of the battery to the price that I have to pay, is around 9,000 euro. So here we have the start of this simple calculation. I have a 9,000 euro battery for a 300 kilometer range. So what I would argue is, if we put electric roads in place, we will no longer need ranges that are up at this level of 300 kilometers. I think that if we put e-roads in place, so electric roads, let's assume then that we only need a range of 150 kilometers in our electric vehicles. That means our battery is now only 4,500 euro. So what we've effectively done is we've saved 4,500 euro in every electric vehicle that we sell because we have a smaller battery on board. And what makes this so fascinating is, I just pointed out earlier that we need 3.3 billion euro to build this road from Paris to Berlin. How many electric vehicles would we need to sell with smaller batteries in order to justify the construction of this road versus not constructing the road and buying batteries that are much bigger? So if we take the three 0.3 billion, and we divide it by the 4,500 euros that we save for every vehicle that we sell, well, what this shows us is that we need to sell 730,000 electric vehicles with smaller batteries, and then use the money that we've saved to build this electric road rather than relying on bigger batteries. Now, 730,000 electric vehicles may sound like a lot, but if you look at the number of cars in the EU in 2015 that were sold, it was 13 million. So in Europe in 2015 we sold 13 million cars just in that year. If we managed to get 2 or 3% of those that turned out to be electric vehicles, or maybe 5% I think off the top of my head that were electric vehicles, so if we managed to sell 730,000 electric vehicles out of the 13 million cars we sell in Europe every year, if those 730,000 had smaller batteries, then we would have saved enough to build a electric road all the way from Paris to Berlin, just by building smaller batteries in the cars rather than putting that money into bigger batteries in the cars. And if you imagine we're selling these 13 million cars in Europe every single year, in the future you could imagine maybe half of those car sales being electric, which means every year we're selling enough. If you imagine 5 or 6 million of these cars being electric, that's enough to build maybe 5,000 or 6,000 kilometers of electric road every year due to the savings of having smaller batteries rather than bigger batteries in the electric cars. So this is how, if we stop spending money individually on bigger batteries and start spending money collectively on electric road infrastructure, we as a society could actually provide electric transport at a much cheaper price than us all doing it individually with bigger batteries. So a small battery plus an electric road infrastructure is cheaper than a bigger battery that has a long range. And I've done a detailed calculation on this using Denmark as a case study, where I've not only compared electric roads with battery electric vehicles or big batteries, but I've also compared it with petrol and diesel. So please check out the report if you're interested. And I think that two of the most important benefits of all of this are not only that it's something that's affordable, but also that electric roads could actually facilitate the electrification of heavy-duty transport such as trucks and buses. That is a really significant add-on benefit of all of this. And I've only done the calculation on the board here for cars, but I've also included buses and trucks in my report. And the final thing I could just mention is, if we actually have a physical electric connection on the road, I believe that that would also facilitate a much more creative and imaginative way of self-driving vehicles than what we have right now, which is in terms of relying on radar and so on. But these are more external benefits that will be externalities to what the calculations I've done illustrate. So please check out the report if you're interested, and let's hope that it accelerates the implementation of electric cars into the future. Thanks for listening.